Hello, welcome back to LeetCode Daily Live, where I do the LeetCode Daily Question, raw and uncut. Today we have a medium. I'm so sorry about yesterday's cutoff, but essentially I used a stack for yesterday one. So if you want me to make another video about it, please leave a comment. So yeah, let's get started. So we want to construct binary tree from preorder and postorder traversal. I think I might have done this before, but let's see. So given two integer arrays, yeah, so you have the preorder and then you have the postorder, like traversal, and you basically want to reconstruct the tree and return, return the binary tree, and if there exists multiple answers, you can return any of them. So I think that would be like, let's say you have like one tree, so yeah, so let's say you have, I don't know, like 1 and 2. So actually, are they the same? Let's think about it. So preorder would be a preorder would be DFS, like, because every time it sees a node, it is going to, well, it is going to return it first. Yeah, and postorder would be, postorder would be, you look at, like, you go to both your left and right first, and then like you return yourself. So let's write that down actually. So preorder, it will be DFS. So you have like print, and then you go left and right. Postorder, well, you go to left and right first, and then print. So actually, for this case, it should be different. So the preorder, like both of the preorder is going to be 1 and 2, but then the postorder, well, actually, both of the postorder is going to be like 2 and 1. So like for a case like this, we can return either of them. Basically, that's what it means. Yeah. So the preorder length. So preorder is going to be the array. So the length is pretty small. It's only 30. All the values of preorder are unique. Okay. And the length of the two arrays, of course, they are the same. Right, and apparently is like the values inside are 1 to n as well. Well, that's just guarantee uniqueness, so we don't really have to worry about that too much. Yeah, so maybe we have to think about the different cases first, I think. So yeah, why don't we just look at the complete binary tree? Like that should tell us a lot, I think. So we have what do we have? So we have like 1 and then 2 and 3, right? So for the preorder array, so we have 1 and then 2 and then like 2 children, and then we have 3 and then 3 children, right? But for the postorder, it's kind of reversed, right? So what do we have here? We have 4, 5. Yeah, so we have like 4, 5, and then wait, look at 2, and then we have what else do we have? We have like something else, and then like we look at 3. So we have to think about where the subtrees are for each of these, I think. Right, and I think like we have to find a way to basically like check where the subtrees are, so we can like break it up, and then like we can go a bit, like, and then we can, like look inside there, and then like we can basically keep going. But yeah, let's think about this. So like obviously for this case, well, we have two right after one, so we know that like we know that one is going to be the start because we are doing a DFS. Like one is like whatever comes first is going to be the root. That's very obvious. And we are guaranteed that we always have a root as well because the length is non-empty. The next thing is going to be its child, right? Like if it doesn't have any child, it will just like not go anywhere basically. So the next thing is going to be either, well, one's left child or so does the post order give us any hint as well? That's what we should figure out. Well, actually for one as well, for one here, well, we know that yeah, let's go to the drawing board. Like we know that the last thing is going to be a root because we are doing a post order. And then what else do we know? We know that the last number, so the number right before the root is going to be its child, right? Because well, like when we go to root, like we go to like both left and right first, and then so it returns like all its subtrees and stuff, but then at the end it will return itself, and then like back to the root, right? So again, we have two different cases. So either 3 is the left child or the right child. Well, but if we look at this here, well, we know that like both 2 and 3 are one's child. So we can actually do that to single out like where the children are. So like we can find, well, 2, and then like this is 2 sub 3, then we have 3, and then this is 3 sub 3. So we can basically like do this recursively, and then eventually we will find the answer. Yeah, so I think that's the solution, but well, we still have to look at like how we can cut the post order. So like for preorder, yes, well, if this is 2, we know that like if these are different, like different, we know that well, like the root is going to have like 2 children. But if it only has 1 child, so let's actually draw up another case here. So I don't know, let's say we have like 1, 2, and then a sub 3 down here. So the pre-order is going to be like 1, 2, and then a sub 3, right? The post order is going to be whatever the sub 3 is going to print, and then goes to 2 and then 1. So I guess like we just always like put it on the left because like it says any tree, like any valid tree is alright, right? So well, of course like 2 can also go this way. That will give the same answer, but we just have to print one unique one correct solution. So let's just like do it on the left. And if there are if one is a leaf node, well, if it is a leaf node, it shouldn't have anything like in a sub tree, right? So like nothing here. Well, so it should only have itself in like whatever section the pre-order and post order has. So maybe we can go back to the complete binary tree case. So we have this. But the question is, how do we know where? Like, how do we know where we are going to cut like the subtree down? So, well, if you look at 3 here, so this is like we know that that's going to be the right child, right? So, well, if you only have if it only has 1 child, so something like this case, well, it's very simple because we know that everything like after 2 is going to be, well, like it's sub 3, right? So we know that it's going to be something like this. So it's going to be like 2 connected to like something, or maybe more things, but like you get the idea. Like this whole thing is going to be like the subtree where 2 is the root. But if we have, well, 2 children, it's going to be slightly more trickier. But if we think about it, when we get to 2, like on post order, everything in all of the things in the subtree of 2 will have been gone through already. So we can guarantee that like this is the subtree here. So we can just like get that cut, and then like for 3 it's just gonna be like whatever is after 2, but like so like all these is going to be 3 subtree. So you just have to find the correct position for them. Well, I think like I still have to work through this example to be like exactly sure on like the correctness of my solution. But yeah, so let's say we have 2 now. Yeah, we have 2, and we want to form the subtree. So what will we have? We have like 2, 4, 5 here, right? Like for pre-order, and then we have 5, 4, 2 for post order. So what does that mean? Well, if our front and end is always the root of the tree, like, or the subtree, just like how 1 is like for the full case. Well, we know that this is going to be the left, this is going to be right. If they're the same, we know that well, it is if it is the same, we know that it is going to be, well, 1 child, and then like everything else is going to be like that child subtree. Otherwise, well, we just get whatever is after 4, whatever is after 5, and then whatever is before 4, whatever is before 5. And yeah, so basically like we just keep doing that. So we build for 4, and then we build for 5. Well, but when we get to 4, like both the pre-order and post-order only has 1 element, right? So that means it is going to be a leaf node. So we can just create that node, and then we can return it. Yeah, so I think it's a recursive kind of problem. And yeah, and that should work. So let's get coding. Yeah. So let's see. So we want the length. We probably want the length. So number of nodes is going to be the length of either of the array. And then we want, like, I think we can just get the start and end. And we want to build we want to return a node for that. So we can just do return. I think my Wi-Fi went out again. This is quite unfortunate. But yeah. Yes, let's get back to coding. So so we want the start and end. Let's do exclusive end, because usually my experience is that usually if you do exclusive end, it comes out to be a bit nicer. So we want to have our function here. So build tree, and so we will have a start, and then we will have an int, an end. So like that will be the. Oh, actually, we need that for both the pre-order and the post-order, because like let's say we are building for this, like the 2, 4, 5 subtree, right? We need this in pre-order and we need this in post-order. So we actually need like 2 different intervals. So maybe we can call this like pre-start, pre-end, and post start, post end, and then it should return an optional tree node. So, well, so if pre-starts, if it is equal to pre-end, so that means, well, because pre-end is exclusive, right? So if they are equal, that means like the current slice we are looking at is, well, 0, like, or 0 length. So we actually don't have nothing. Like we just return none. Otherwise, if pre-start +1 is equal to pre-end, well, actually for this case, we just have to make a node of the value in pre-start, because like this is the case, where you only have 4, you only have one node, and then like you can just return preorder pre-starts. So like that creates a node and then returns it, and then like whatever it got called from, it can just use that and then, well, put it like either on the left or right of like whatever node it got like recurse from. So otherwise we have otherwise like we have the format where like we have the root and then like a bunch of stuff, root, a bunch of stuff here. And we know that this is going to be a left, this is going to be a right element. And because they're all unique, if they're the same, we just put it at the left. So we can just do if preorder pre-start. So that's the root +1 would be its left child. If it is equal, well, to post end, but because it is exclusive, we actually have to do -2 to get to the second last. So we can do that, and then so if they're equal, we just want to actually, let me think about this. So if we are dealing with the roots, I think, yeah, we definitely want to we want to create like the current root, like for the tree or the subtree. So like that should take the value like of pre-start, and then so if they're the same, we can just do like current root dot left, well, is equal to, we want to build the tree from, well, let's think about let's think about like how the tree should look like. So like pre-start +1 is going to be, well, it's going to be like this element, but because they're the same, we want like this whole interval here, so we can ensure that the first element and the last element of the pre-order and post-order slice is still going to be the subtree's root. So pre-start, and then pre-end is going to be the same. Post-start is going to be the same, but then for post-end we want to do -1, and otherwise we know that it is not the same. So what do we have to do if it is not the same? So we want to find so it will look something like this, right? So we want to cut it so that, well, we have 2 and the subtree, 3 and the subtree, and then down here we have like everything up to 2. So like we want to return so like our range should be like this should be the pre-order. This should be the post order for like 2, and then this should be pre-order and that should be post order for 3. So if we have that in mind, well, it should just be let's think about it. So current root dot left, we have to build tree, but where do we want to build from? Well, the start should be +1, but then we have to do something to the end. So new pre-end, and then this start should also be the same, but then we have a new post end for that. And then for current root dot right, we also want to build the tree, but then this time we actually want new pre and yeah, we want new pre-end because this is exclusive. So if this is exclusive, this is going to be the first element like for the next slice, because we are like partitioning it, right? The pre-end is going to be the same because like we have the same end, and then we should have new post end here. So like again, this is coming from the previous slice. So this is exclusive, this is going to be a first element, and then we have post and -1, and that should give us the correct ranges. So now all we have to do is, let's see how many new elements we have. We have new pre-end, new post-end. So we only have to figure out new pre-end and new post-end. So new pre-end, let's make that equal, well, to pre-start +1. Well, we can like for example, two here, it can have no subtree. Then if this is like the pre-start, if this is pre-start, like there's nothing, the next thing it goes to is C3, it is just going to return. So yeah, so we have pre-start here, and while pre-order, actually maybe this should be 2. Yeah, this should be 2, because well, pre-start +1 is going to, it's not going to be like the right child, right? So our new pre-end, but we want the pre-order. So while it is not equal to the right child, and how do you know the right child? The right child is going to be post-order, post-end -2, just as we figured out up there. So while it is not equal to the right child, new pre-end, we want to increment it, and we are guaranteed that like we will see the right child because of how the tree is constructed. And then we have new post-end, which should equal to, well, again, when we get here, so what do we have for so what do we have for post-start? Post-start is going to be the start of here, right? But this could be an empty tree. So as long as we, as soon as we see 2, we just want to add 1 to it, and then, well, that will be the slice where the ending is exclusive. So equal to post starts, of course. And now while the post order of new post end is not equal to the right child, and we figured that out before, this is going to be the left child, so we have that here, new post end plus equals 1, so you increment that, And after we find the index, we actually have to increment it again. So we have we have the exclusive bound afterwards, and everything else should work. And this is quite messy, but I think it should work. Oh yeah, of course, at the end of all these, you want to return the current root. Oh, why is doing this? Build tree required to yeah. So we need both pre-order and post-order, and at the start you have the full thing, right? Yeah. Okay, it seems like it does work, unless I'm falling for edge cases. Looks like I am. Well, that's not good. What is this case? So we have pre-order, which is 2 and 1, and then we have post-order, which is 1 and 2. So what does that look like? It should be so pre-order, so 2 1, something like this, and then 1 and 2. Yeah, so it should look exactly like this actually. Yeah, so let's have a look at this and see where we have gone wrong. Well, so when we build the tree, it's just going to be 0 2 and 0 2. Pre-order is 2, so we know that the root is, we know that the root is going to be 2. So when it looks at the next thing, you should see that like the ones are the same. So apparently not. So let's think about it a bit harder actually. Oh, I see the issue. So like the post order, like the second last element in the post order gives us the right child, right? But I did pre-order there, so just add this case here. Just make sure everything works. Yeah, it works now, seems like. Yeah. Nice. Okay, it works. Yeah, so this question is probably a bit messy, but it's not too difficult to logic with it, I guess. But well, thanks for watching. Hopefully my mic works today, and I'll see you tomorrow. Bye.